You the IM341 Extra Practice number 5 solutions on solving quadratics by factoring. Now there's a puzzle that goes along with this. Let's go ahead and check that out. So here's the puzzle that goes along with that extra practice. In this one, we're trying to solve the riddle, what kind of music do barbers and tailors play together? The idea here is that we've got 10 word problems that we have to set up an equation for and solve, and then find an answer down at the bottom here. Once we found the answer that goes with the question, we just cross that letter out and keep going until we're done with the problems. All the letters that have not been crossed out will spell something out. All right, so let's get to it. First problem is this one right here. 8 more than the square of a number is the same as 6 times the number. Find the number. So I think it's easiest on all of these to just set up an equation. So I'm going to just let n represent the number that we're looking for, the unknown number. So 8 more than the square of a number. How can I express that? Well, the square of a number would be n squared. And 8 more than that would just be adding 8 to n squared. So they're saying that this expression here is, that means equals, the same as 6 times the number. So we could write equals 6n. And this is now a quadratic that I could set up and solve. If I'm going to solve this by factoring, I need to get it in standard form by moving this 6n over to the left side so that I have 0 on one side. So if I do that, I'll have n squared minus 6n plus 8 equals 0. I want that 6n in the middle there because that's standard form. And now since I just have a 1 for my squared coefficient there, I can just ask what are two numbers that multiply to give me 8, what are factors of 8 that add up to negative 6. So 1 and 8 doesn't work, 2 and 4 does if they're both negative. So that would be n minus 2, and then n minus 4. So again, factors of 8 that add up to negative 6. And then setting each of these equal to 0 and solving, 2 minus 2 is 0, so there's one solution. And then we also have 4 minus 4 is 0. Now, we didn't have any specifications on the type of number, so 2 and 4 are fine just the way they are. Let's go ahead and find them down below. I see them right here. This goes with O, so I'm going to cross that one off. Next problem is kind of similar to the first one in the way that it's set up. So here we have 15 less than the square of a number is the same as twice the number. Find the number. So again, we have this idea of a square of a number, which we can again call n squared. 15 less than that, this is where you got to be careful on the wording. What they mean is we have to take away 15 from that, so minus 15. And they said is the same as twice the number. So that means equals 2 times n. Just like before, let's get this in standard form and see if we can factor it. So I can subtract the 2n. n squared minus 2n minus 15 is what I have there, and that equals 0. So now I'm looking for factors of negative 15 that add up to negative 2. So 1 and 15 won't work. 3 and 5 works if I have positive 3 and negative 5. So that's going to be n plus 3, n minus 5 equals 0. Zeroing each of these out, we end up with n equals negative 3 for that first one, and positive 5 for the other one. And again, there was no restrictions on the type of number that we should be getting, so these are both good answers. And I'm going to go ahead and find those now. Negative 3, there it is, positive 5, so that's u that we're crossing off. For this next problem, we have if a number is added to twice its square, the result is 6. Find the number. So a number, that's going to be n, is added to something, so we're doing something plus n. How can we say twice its square? Well, the square of n would be n squared, and then twice that would be 2n squared. So we've got 2n squared, and a number is added to that. So that'll be plus n. And then they said the result is 6. So that means equals 6. Okay, let's get this in standard form and see if we can factor it. It's almost there. We just need to subtract 6 over to the left side. So now we have it all zeroed out. And there's no common factors I can take out of this. So since I don't have a squared coefficient of 1, I'm going to go to the AC method on this. 2 times negative 6 gives me an AC value of negative 12. So I'm looking for factors of negative 12 that add up to 1. This is a 1n. 1 and 12 doesn't work. 2 and 6 won't do it. 3 and 4, if I have negative 3 and positive 4, that would give me positive 1. So I'm going to split up this n into negative 3n plus 4n. Since I have 4 terms, now let me go ahead and use grouping on this. So I can take an n out of the first 2 terms. That leaves me with 2n minus 3. For the next 2 terms, I can take out a 2, leaving me with 2n minus 3. So 2n minus 3 is my common factor that I can take out of all that. And my leftovers, n plus 2, goes in a parentheses next to it. Now we have to go ahead and set each of these factors equal to 0 and solve that. So if I have 2n minus 3 equals 0, I could add 3, divide by 2 to get 3 halves as one of my answers. And then for n plus 2, negative 2 zeros that out, so that's my other answer. No restrictions on our numbers, so let's just find those down below. We've got 3 halves and negative 2. That's right here, so that goes with t, so cross that off. Here we go with number 4. 7 less than 4 times the square of a number is 18. Find the number. All right, well, we're doing 7 less than, so that means we're going to do something minus 7. So let's hold that thought. 4 times the square of a number. Well, that's going to be n squared times 4, so 4n squared. And then we want 7 less than that, so minus 7. Is means equals, so is 18 equals 18. All right, let's go ahead and solve this. I'm thinking if I subtract that 18 over to the left side, that's one way if I'm going to do this by factoring anyway. There's other ways to solve it, but let's use factoring. So negative 7 minus 18 gives me negative 25. And in doing this, I notice that I've actually got 2 perfect squares. So when I go ahead to factor this, I can use my a squared minus b squared shortcut right here, where I square root the 2 things and stick them in a plus and a minus parentheses. Square root of 4n squared is going to be 2n. Square root of 25 is 5, so 2n plus 5 and 2n minus 5. Now let's set each of these equal to 0 and solve. For 2n plus 5, I can subtract 5 and then divide by 2, so negative 5 over 2. For this next one, I'm going to add 5 and divide by 2, so positive 5 over 2. No restrictions on the numbers. We've got 2 fifths, or 5 halves rather, negative and positive. That's down here with O, so there we go. This next one is getting a little bit trickier now. We want to find 2 consecutive integers whose product is 56. So how can I represent consecutive integers? First off, what does that even mean? Well, consecutive means one right after another. So for example, 2, 3, 4, those are consecutive integers. So how can I represent all the consecutive integers out there? Well, if the first integer is n, then the next one after that you could say is going to be n plus 1, like 2 versus 3. And I need the product of 2 consecutive integers. So for this I could write n times parentheses n plus 1. There's the product of 2 consecutive integers. Now what about this? Well, they said that product is 56, so equals 56. And this now gives me a quadratic that I can solve to figure out my integers. To do this, I need to get it in standard form, but before I even move things around, I'm going to want to distribute to get rid of that parentheses. So we've got n squared plus 1n equals 56. And then I'm going to subtract 56 to zero this out. So since I have a 1 for my squared coefficient, I can just figure out 2 factors of negative 56 that add up to 1. We have an invisible 1 next to that n. So let me think. 1 and 56, no. 2 and 28 doesn't work. 3 doesn't even go into 56. 4 and 14 multiplies to 56, but doesn't get me 1 in any way. 5 doesn't work. 6 doesn't work. Let me think. 7 and 8. 7 and 8 go into 56. And I can get 1 out of that if I have a negative 7 and a positive 8. So I'm going to write n minus 7 and n plus 8. That gets me 2 n values that zero each of these out. So for this first one, I have n equals 7. And I also have n equals negative 8 for this next one. Now they're looking for 2 consecutive integers. 7 and negative 8 are not consecutive integers. Those are the first integer. Those are n. To get their consecutive counterparts, I need to add 1 to each of these numbers that I just got for n. So I'm going to find my n plus 1s now. For 7, n plus 1 is 7 plus 1, so that's 8. So we have 7 and 8 is one set of consecutive integers. And then for negative 8 plus 1 gives me negative 7. So negative 8 and negative 7 is the other pair. Looking for 7 and 8 and negative 7 down below here. There's a negative 7, not the stuff I need though. There's a negative 8, again, not the stuff I need. All the way at the very end, we have our two pairs of numbers. So we'll cross off the G. For number 6, we want two consecutive positive odd integers whose product is 35. So there's a lot of conditions on these integers. Whatever answer we get, note that it's going to have to be positive and odd, or else we're going to have to throw it out. So how can we write this in algebra form? So consecutive positive odd integers. Well, that would be like 1, 3, 5, that kind of thing. Let's say that my first integer is n. What would be the next odd integer after that? To get to the next odd number, I have to skip a number. So I don't have n plus 1 like I did on the last problem. Now I have to do n plus 2 to get to the next odd number. And I have a product of these two integers. So I have to do n times parentheses n plus 2. And then they said the product was 35 rather. So equals 35. Just like before, I'm going to distribute and put this in standard form and then hopefully be able to factor it. So we've got n times n is n squared. N times 2 gives me a plus 2n. And then for my next step, let me subtract the 35 to get this in standard form. Great. So now I'm looking for factors of negative 35 that add up to 2. 1 and 35 doesn't work. I think 5 is the next thing that goes into 35. 5 times 7, that gets me a 2 if I have a negative 5 and a positive 7. So n minus 5, n plus 7 are my factors. Setting each of these equal to 0 and solving, we've got 5 for that first parentheses, and then negative 7 plus 7 zeroes out the next one. Now before I go ahead and find the corresponding consecutive positive odd integer that goes with each of these, negative 7, although it's odd, it's not positive. So I actually have to throw that out before I start looking for final answers. But that's a good thing. It's less to worry about. So now I have 5, and I have to find the next odd number after 5. So I need my n plus 2, which in this case, 5 plus 2 is going to give me 7. So 5 and 7 is my actual set of answers that I'm looking for. And I see that right down here next to the A, so cross that off. For this problem, they're telling us the sum of the squares of two consecutive integers is 41. Find the integers. Well, there's a lot going on in this one. If I have two consecutive integers, then I can call them n and then n plus 1. Again, consecutive means one right after another. So what am I doing with n and n plus 1? Well, I have the sum of their squares. So I need to square both of them, and then I have to add those squares together. So I'm going to have n squared plus parentheses n plus 1 squared. This is the sum of the squares of two consecutive integers. And they said if I do this, I should get 41, so equals 41. All right, this is going to be a little bit of a mess initially, so we're going to have to distribute out this parentheses and get everything in standard form. So expanding this, this n squared can stay where it is, but I'm going to use my a plus b squared shortcut here, so square the first thing, multiply them and double it for the middle, and square the last thing. So I've got the n squared that I started with, and now this first item squared is another n squared. N times 1 doubled is going to be a plus 2n, and then 1 squared is going to be 1, so plus 1. And all that still equals 41. Now, if you're having trouble seeing where I got this n squared plus 2n plus 1 from, I did use a little shortcut there. If you don't like the shortcut, you can write out the n plus 1 parentheses twice and just FOIL it out or lobster claw it out using distribution. All right, so let's get this in standard form. These n squareds, I can add those together to get a 2n squared. This 2n is fine where it is. It's already on the same side as the n squared. And then this 41 needs to come over to the left, so 1 minus 41 gives me negative 40. And then as a next step here, if I'm going to factor this, before I do that, I can actually divide this whole thing by the common factor of 2. Or I could take out a 2. Either way. So that's going to give me n squared plus 1n minus 40 divided by 2 gives me negative 20 there. And then 0 divided by 2 is still 0. So now I'm looking for factors of negative 20 that add up to 1. 1 and 20 won't work. 2 and 10 doesn't do it. 4 and 5 works if we have negative 4 and positive 5. So I'm going to write n minus 4, n plus 5 equals 0. So zeroing each of those out, we end up with 4 for that first one and negative 5 for the next one. Now I need two consecutive integers. So I need to find the n plus 1s that go with 4 and negative 5. For the 4, n plus 1 for that is 4 plus 1, so 5. And then negative 5's n plus 1 is going to be negative 5 plus 1, or negative 4. So I have 4 and 5 are one set of numbers, negative 5 and negative 4 are the other set. I see that right down here toward the end, so that's n that gets crossed off. For this one, we have two consecutive odd integers such that the square of the first added to 3 times the second is 24. All right, so let's think about our numbers here. Consecutive odd integers. We can call them n and then n plus 2, because I have to add 2 to get to the next integer. So what am I doing with n and n plus 2? Well, they said that the square of the first added to 3 times the second is 24. I can add things in either order, so I'm going to write n squared first. And then I'm adding to that 3 times the second. So that's going to be 3 parentheses n plus 2, and I'm adding that as well. And then finally, the result is 24. So equals 24. All right, let me distribute this out and put this in standard form so I can maybe factor it. N squared is good where it is. 3 times n is plus 3n. 3 times 2 gives me a plus 6. 24 is still there. But now I'm going to subtract 24 to get standard form. 6 minus 24 is a negative 18. So that all equals 0. Since I have a 1 for the squared coefficient, I can find factors of negative 18 that add up to 3. So 1 and 18, nope. 2 and 9, does that work? Nope. 3 and 6 works. Negative 3, positive 6. So we have n minus 3, n plus 6 equals 0. Zeroing out each of those factors, we have 3 for the first one, because 3 minus 3 is 0, and then negative 6 for the next one. Now, before I go ahead and find the next odd integer, let me figure out if both of these are good answers. We needed consecutive odd integers. So 3 is an odd integer, so that's good so far. We'll find the next one for 3. Negative 6 is not odd. It doesn't matter that it's negative in this problem. They didn't specify that, but it's an even number. So we're going to cross that one off. But now the n plus 2 that goes with 3, that's going to be 3 plus 2, which is 5. So we have 3 and 5 that we're looking for down below here. And I see that in the very beginning next to the s. So cross that one off. This problem, we want 2 consecutive even integers so that the square of the first decreased by twice the first. The square of the second decreased by twice the first is 52. All right, say this 5 times fast. So what are my integers looking like? Let's let the first one be n, and then the next even number is going to be n plus 2. So you might be thinking, well, didn't we use n plus 2 for the consecutive odd integers? We did. If you want to get to the next odd number or the next even number, if you're starting at the same kind of number, you're always adding 2. So we have the square of the second number. So that's going to be n plus 2 squared, decreased by twice the first. So we're subtracting 2 times the n. And then they said that is 52, so equals 52. All right, we're going to have to expand this n plus 2 squared out, put all this in standard form, and then hopefully factor it. So squaring the first thing gives me n squared. Multiplying these and doubling it gives me a 4n, a plus 4n in the middle. And then 2 squared gives me 4. And again, you could write out n plus 2 twice and FOIL it out and simplify to get this. Now don't forget, you still have that minus 2n that you started with, and the 52. So let's get everything over and combine stuff on the left side. N squared is good as it's going to get. 4n minus the 2n that's already on the left side is a plus 2n. And then 4 minus the 52 that we're moving over here is negative 48. So that all equals 0. Since I have a 1 for the squared coefficient, I'm just looking for factors of negative 48 that add up to 2. So let's see, 1 and 48, we've got 2 and 24, 3 times 16 doesn't work, 4 and 12 doesn't work, 6 and 8 works, negative 6, positive 8. So we have n minus 6, n plus 8. That gives us n values of positive 6 and negative 8 to zero out each of those. And now we wanted consecutive even integers. Well, these are both even. It doesn't matter that one of them's negative. They didn't say it had to be positive. So we're going to find the n plus 2's that go with 6 and negative 8. 6 plus 2 gives us 8, and then negative 8 plus 2 gives us negative 6. So we have 6 and 8 are a pair, along with negative 8 and negative 6. I see those pairs of numbers right here below the I. So there we are. And we're on to the final problem. Here we go with our final boss battle. 3 consecutive positive integers such that the square of the first increased by the last is 22. Well, what are these 3 integers? We can call the first one n, the next one would be n plus 1, the next one would be n plus 2. So we said the square of the first, that's n squared, increased by the last. So we're adding n plus 2 to that. And we don't really need a parentheses because we're not doing anything, we're not multiplying it by anything, just straight out adding it. And then they said is 22, so equals 22. So that's not a horrible setup. We just have to subtract 22 to get standard form. So 2 minus 22 is negative 20. And now I just need factors of negative 20 that add up to 1. So that would be negative 4 and positive 5, n minus 4, n plus 5 then. Zeroing each of those out, we've got 4 and negative 5. However, they said that we needed consecutive positive integers. So negative 5 can get thrown away. And then we have 4 and the 2 integers after that, which would be 5 and 6. So 4, 5, 6, let's find that. Let's see here. That's right here next to H, so cross that off. Last, we come to the part where we solve the puzzle, just collecting the letters we haven't crossed out and seeing what it spells out. So we have a C, L, I, P. I think clip maybe is all one word. The next word we have S, E, W. So clip, sew. What kind of music do barbers and tailors play together? Well, the clip and the sew clearly have to do with barbers and tailors, cutting things. And if you are wondering about the music, calypso, I believe, is a type of music. So it's a little pun there. Till next time, Mr. Sutton signing off.